Okay, today I'm gonna talk about the posterior spinocerebellar tract, and this is the topic of this live. And what is the posterior spinocerebellar tract? Is a neural pathway that plays a crucial function in transmitting proprioceptive information from the body to the cerebellum. And I'm gonna start talking about let me maybe talk about the fibers of the tract, okay? The fibers, what are the fibers of the tract? Are basically the fibers of the tract of the posterior spinocerebellar tract are basically axons from the thoracic nucleus of Clark. And this part here, posterior spinocerebellar tract. Cerebellar tract. And the fibers of the posterior spinocerebellar tract, they are axons originating from the thoracic nucleus of Clark, and that this nucleus is located in the dorsal horn of the spinal cord, specifically in the thoracic and the upper lumbar segments. Okay, so thoracic nucleus of Clark. And these axons ascend through the spinal cord on the same side ipsilaterally as their origin, okay? Ipsilaterally as their origin. Now, thoracic nucleus of Clark. Okay, so let me just mark here. They send all the way to the cerebellum. The main function, okay, of this tract is carry proprioceptive sensations. Proprioception refers to the sense of the body position, movement, and muscle tension, basically the body awareness, which is essential for coordination and also balance. And the information carried by this tract helps the cerebellum to process sensory input related to limb and trunk movements, and it will help with the fine-tuning of motor control, which is essential for movement. Now, as you can see here, the axons travel upward within the spinal cord and eventually reach the inferior cerebellar peduncle, which is this structure here. Inferior cerebellar peduncle, which is this one here. Okay, so reach this part, and this part is also known as a rest form body, and the inferior cerebellar peduncle serves as the main conduit for these fibers to enter the cerebellum. Now, upon entering the cerebellum, the fibers terminate in the cerebellar hemisphere on the same side, ipsilateral, as their origin. and this ensure that the proprioceptive information is processed locally within the cerebellum to coordinate the motor functions. Let me just finish this part here. This is the cerebellum. Okay. Usually, if this area, the posterior spinocerebellar tract, is injured or suffers some disease, the patient might present deficit in proprioception, which results in impaired balance and coordination. And also, patients might present or experience difficulty in performing precise motor tasks such as walking or manipulating simple objects like a pen. Now, there are a few when comparing with the other tracts, unlike the anterior spinocerebellar tract, which is this one here, this one also carries proprioceptive information, but ascends contralaterally, okay, crossing over to the opposite side. The posterior spinocerebellar tract, remember, remains ipsilaterally through all its course. So let me just write here the anterior spinocerebellar tract. Okay, so we have here the spinocerebellar tract, and let me just differentiate from the posterior. Just to sum up, okay, thoracic nucleus of Clark is the source of axons forming the posterior spinocerebellar tract. Posterior spinocerebellar tract. Anterior spinocerebellar tract is another tract that will carry proprioceptive information but ascending contralaterally. Posterior spinocerebellar tract carrying proprioceptive information ipsilaterally. And then we have the inferior cerebellar peduncle, that is the structure through which the tract enters the cerebellum. And the cerebellum here. Okay, the cerebellum is the target. And is where the tract terminates, and facilitating, it's here that we will be facilitated the motor coordination balance. And yeah, this is what I wanted to share. What I'm gonna do now, I'm gonna just finish this part here of this drawing, and tomorrow I will come back with another video. And yeah, that's it. Thank you so much, and I will see you next time. Let me just finish the live.